Hey, thanks everybody for joining us at lunchtime again. It's if you haven't joined us before, welcome. If you've joined us in this series, thank you for coming back. I hope you're enjoying your nice roast beef sandwich while we're chatting today. Little different background. I'm actually in a hotel. We might be getting a little bit of echo sound. It's not from the comfort of my office with two computer screens, but we're going to get this out to you, and it's going to be quality. Myself, I've been in the HVAC trade since 1982. Actually, if anybody has a chronological order on battery powered tools, that was before the advent of the first cordless drill. So I go back a ways. NATE certified, been NATE certified since the beginning of that certification program. I still carry, after all these years, the heat pump install and service. Fortunately, I have technicians working for me that can do the service now. Also, 2009 and 2010 went through the CBPCA program, now Efficiency First, and obtained my BPI credential. And at that point, I realized that once I knew the truth about how things needed to work, I couldn't go back. I couldn't go back and install systems that weren't good for the house and didn't work well for the house. So it was a big paradigm shift and change in my career. That time we were doing a lot of installing small, but with gas. I feel like I've sold enough heat pumps in the last few years to kind of get my karma straight. I've only been installing heat pumps since 2015, almost all inverter technology, designed to match the house load exactly. We've been doing load calcs for hundreds and hundreds of them. And then in 2020, there needed to be a voice in electrification. We needed to pull away from the traditional HVAC company, give customers a good solution. So I felt it was kind of an opportunity to get into the business of electrifying homes only. So if you call our company, we won't come fix your gas furnace. We won't come put a new one in for you. We only do electrification, and it's a beautiful thing. We're a mission-driven company, Electrify My Home. Our mission is to provide the most efficient, cost-effective electrification solutions, to practice good stewardship of the electrical panel, which means we make wise decisions on planning to make sure that our systems use as little energy as possible and as little breaker space as possible. And then to train and influence other contractors to do the same. We have a training program with a few different entities, including Tech Clean California, which is what puts me in this hotel room down in beautiful Monterey Park, California. We are having 3-day training starting tomorrow. So glad you joined us. Thank you so much. Let's get right into it. The agenda today, we've already covered part of this. We're going to cover the consultative approaches to identifying needs and matching solutions to customers that are looking for electrification solutions today. And the audience for this is generally salespeople or people that want to be able to talk to their neighbors and friends and just understand what some of the common objections to heat pumps that we hear out there. And you know, one of the things we did that was looking back on it pretty smart is as Electrify My Home, we don't get a lot of objections to heat pumps. We only have people calling us for them. So our life has gotten easier since we did that. But my first part of my career when I was selling heat pumps, it was all transversing furnace customers over to investing more and getting a heat pump installed. At the end, there's going to be a class survey. We'll close and wrap up, and we'll deal with any questions. And Alex is on to answer any questions as we go, and whatever comes up at the end. This is number 4, as Javier said, number 4 in our Electrify Efficiently series. We are so proud to present this to PG&E. Join us again in 2 weeks for Heat Pumps Done Right. We're going to have a really couple of great case studies. And then on the 4th of April, why we need to include home performance for electrification to have good outcomes. Today, our area of focus is going to be building electrification, our area of focus for the entire series is building electrification. Single-family residential is what we concentrate on. HVAC and water heating is primarily what we do. Overcoming home electrification barriers by properly conditioning our customers to understand that life will be different with a heat pump. We are going to talk about approaches that optimize for comfort, efficiency, resilience, and lower operational cost. And I think all audiences will benefit from this, but today is really contractors and people that just want to be able to talk about heat pumps with maybe that neighbor that has all the objections on why they don't want to convert from gas. Maybe we can give you a little bit of ammo today to help with that. So our consultative approach to identify needs and matching solutions, there's 6 steps that we're going to talk about before we go into the actual objections. One of the most important things that we find is that if we inform our potential customers properly and we set the expectations through the presentation side of everything, it really narrows down the amount of objections that are at the other end. So going through the process and understanding what most consumers are going to be aware of and also afraid of with this is really important. And having a good presentation is good for that. So before we jump to addressing objections, there's a few things that we want to do during the process. Is we really want to be able to understand who our client is. And there's things that we do, and we're very aware of this thing called DISC, and we'll get into that a little bit more in a few minutes, but it's understanding personalities and being able to pinpoint the type of personality of the person that you're talking to at the time is really, really important in the sales process. We want to also know what their concerns are so we can figure out what their needs are. And then once we get to people's needs, we don't have to talk about anything else. We just need to be able to discover the needs. But in order to do that, we got to dig in a little. We also need to understand their home. So if they've had anything done to the house, and maybe they've got a wire ran for the new heat pump water heater, or maybe they've converted everything to gas from electric and all the electric is already in there, like I did in my house 25 years ago when I moved in. I converted all my electric appliances to gas because I was a gas guy, and which made it a little easier to convert things back because I had plugs and stuff in the wall already. So what's been done already is really important. The panel, the electrical panel, is also very important. We want to understand what that's about, what the condition of it is, if it's one of the 3 brands of panels that that you want to watch out for, and understanding like how do we expand an electrical panel that's it's full of breakers but it's not at capacity. So we want to really evaluate what space is available for us to electrify the home. And then once we get that part taken out or taken care of, we want to have the time to address the objections. And objections are really, objection is a word that's used in the sales side a lot, but it's really just answering questions, right? Discovering what the questions are, bringing them out into the light, and then answering them in a way that informs the customer, and we're not trying to trick a customer like normal sales kind of things do, or we want to understand the customer and take those objections or questions that they have and answer them in a way that really focuses on what their needs are. The biggest thing you have to do as a salesperson, and when I was a head salesperson at a larger HVAC company for about 15 years recently, before I started this business, one thing I always told my guys is you have to go prepared. We have to know who the customer is. We have to have all the information we need, and we have to be able to speak in the language that they're most comfortable with. So one of the things you can do is you can use the content from this Electrify Efficiently training program to kind of load your gun, get ready, and have everything you need to be able to discuss anything. Because bringing up a point when you don't have anything to back it up can be very uncomfortable in some sort of a consultative sales process. And get your facts straight. We're seeing this a lot out there right now where customers are not really getting great information about heat pumps per se, and they're entering into transactions on systems that they're not going to be happy with because they weren't explained how it was going to operate differently, what to expect from it, and how they need to use it differently to optimize the performance and their comfort in their homes. And we're seeing this a lot right now because everybody is out there racing towards the word heat pump, not understanding that when we reduce the capacity of a home, say from 80,000 BTUs of furnace capacity to a 24,000 BTU heat pump, obviously there's going to be a little bit of a different way to operate that system. So guys need to get your facts straight on how this stuff works and make sure that you're informing the customers properly. I always tell the guys that go to our trainings to develop opening statements based on the 5 most important topics, which we'll get into in a few minutes, but get those opening statements and questions in your head and practice them a little bit so you can be smooth with it and introduce the topic to the customer in a way that it's tailored towards their personality type. Understand your products. By all means, this is the most important thing when it comes to heat pumps. Is there's one word, heat pump. That's actually 2 words. There's one category, heat pump, but there's a whole bunch of technologies within that category. We really need to understand our products and have the availability to more than what we just call the page 13 heat pump. And the page 13 heat pump is basically when you call the big box guy in and he's got his catalog open and he's showing you a heating and cooling system. And you say, I really want a heat pump. And they go, oh yeah, I have a heat pump right here on page 13. This is what you need. And so this happens a lot. And we have some great stories around that we'll share over a beer sometime. And have faith in your solutions and back them with building science. So we are a home performance company as well as an electrification company. None of our projects get installed without some level of what we call load reduction or building science improvements or building performance products. A lot of insulation and air sealing and that sort of thing. And this is a big one right here. After going to being in the trade for almost 40 years, I've been to a lot of different sales courses and they all have kind of their own version of this. And one of the things we're always taught is to never assume your customer by the way the house looks. And that's really a term that's based on this house down here on the bottom right. And it would be wrong to assume that customer didn't have the wherewithal just because they don't really clean up their yard too much. But as we look at these photos here at the top left, it's pretty easy to understand what that customer might be into. Obviously, they're showing off their electric car and their solar panels. So these guys are really going to want a real efficient system. And the picture on the top right, we might not want to sell that customer. These are visual people. They're very into how everything looks. Might not be a great sale for a bunch of wall-mounted units and put a bunch of line cover track all over the outside of this house. And believe it or not, we have some pictures that would really surprise you of beautiful homes where I'm sure the customer didn't understand what they were going to get. And they run all these veins of line cover so they can put these units in individual rooms. So make sure you check it out before you go out there. You can find the houses I always take a peek at them on Street View, look at them on Redfin to see if I can find pictures of the inside, Zillow or whatever. Do a little bit of research and find out how long they've owned the house and see if you can get some pictures of the inside. Step 2, just be observant when you approach the customer's home. Look for clues that can help you. The one that kind of stumps us all is the lower left picture there. And it's an interesting home. It's obviously not a California home. There's a lot of solar here, there's a little snow on the roof, and there's a big Hummer in the front yard. So that one might be a little harder to figure out. But when you see things like the solar panels and the modern home design and the drought tolerant landscape, that picture there on the right bottom is not drought tolerant landscape, although all that grass is going to die as soon as the rain stops. So approach, observe your environment, and get it into your mind before you enter the home what this customer's kind of focus might be. We always tell our salespeople to take some time and build rapport. This is where you're going to listen to the clues from the homeowner to figure out exactly what it is that they're looking for. Always, 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 and I have a great story about a window guy that came to sell me some windows, and this was a number of years ago, and they came in, and I don't have a big Taj Mahal house, but I have a fairly nice home in a modest neighborhood. But we've done a lot to it, and the person that came in to sell the windows didn't spend any time building rapport or looking at the house or being complimentary of the things we done. So I knew within the first 5 minutes of him coming into the house that I wasn't going to buy from him. And then I have a really long story about that we don't have time for today. And look for conversation starters. Is there a boat in the yard? Are you into that? Some fishing line or pictures of something you might be interested in, just to kind of close that gap with the customer and be able to start a conversation. And at this point, this is when you're going to take the time to really pinpoint the personality type. We'll go into this a little bit more, but there's 4 basic personality types that everyone in the world kind of lives in, these 4 personality types. And you can be a little more one way than the other. Those types are analytical people, empathetic people, influencers, and the alpha driver. The influencer, I'm an influencer. I like to talk to people. I like to get the word out. That's what I am. I really like talking to other people that are kind of that same ilk. Then we have the empathetic customers. Those are the ones that really just want to do what's right for the environment. And then the analytical ones that we're going to have to give data, and more data to get them across the finish line. And then the alpha driver, that's the guy that we know as air conditioning people. I'm not sure how many of those are on the call today, but that's when you ring the doorbell and you hear the garage door open, because they don't want you to come in the house. They want you to go directly to the furnace. And you can always spot those guys. These are the 4 basic personality types. We have the dominance group, the enthusiasm group, which is the what I am. The steadiness group, those are the people that are going to really want to do that research, and we're going to have to support them with a lot of data and make sure that all the answers or all the questions are answered. And then the conscientious group are really, those are the ones that we're doing a lot of work for right now, because those are people that are willing to invest in what they feel is right for the environment. And it takes all of these type of people to make the world go round. And as you can see the black dot in the D there, some people's personality can be a little bit more dominant and close to conscious, I'm not going to try to pronounce that word. So once we know what our own personality type is, and there's places online where you can go do this if you're just super curious about it. It's called the DISC profile, and probably a lot of you have already done it. But I've taken a few DISC profiles over my career, and they've changed slightly. Since I've become an owner of a company, my I is a little closer to the D. But they're always going to peg these people on what they are. And once you know what your own personality type is, it's really easy to pick out the personality types of our buyers. It's really, really it's important to understand what your customers' needs are. So we tell everybody all the time, you have 2 ears and 1 mouth. You need to use those in the right order when you're communicating with customers. We need to ask questions and listen. Listen to what the answers are. Those questions are going to reveal other issues or subjects. And if we ask a question and it doesn't reveal anything, we need to go on to another question. But those follow-up and probing questions after that open-ended question is where you really get down to the details on what this customer is thinking. And so we can have arguments with our neighbors. I have a neighbor that is, I put a heat pump in his house last year, but for the past 10 years, he's been naysaying kind of the electrification movement and why it's crazy. And I'm like, this is where it's going, man. So I knew because of his personality type, I eventually won him over. And make notes regarding your customer's most important needs as you're doing this, and readdress those needs through the process. It's really important when we're doing this to do a really good site evaluation. So heat pumps don't work well with poorly insulated houses and bad ductwork. So we have a lot of customers that call us and they say, well, I got a furnace installed 10 years ago and I have this ductwork. And I say, well, I'm not sure how much care that guy took in putting the ductwork in. We're going to have to look at those and see if they're going to work out. Sometimes we can use old stuff, but not that often if we're going to do a heat pump correctly. So that attic evaluation is really important. We want to give a lot of attention to the ducts, inspect the insulation for quality and R value and rat leavings. Looking for interstitial wall cavities. If we don't know what an interstitial wall cavity is, it's anywhere we're in the attic and we can see down past the ceiling. So sometimes in two-story houses, especially when there's a unit in the garage and there's ductwork in the attic, there's a big cavity that goes up somewhere that takes that big trunk line up into the attic. And very rarely are those sealed off at the top. Just sealing those interstitial wall cavities can make a big difference on how a heat pump is going to work. Because remember, we're trying to heat the house with a lot less capacity. We also want to look for bald spots in the insulation, make sure the light cans are IC rated, and then the bath fans are connected and venting outside. And then while you're there, note all the gas appliances in the house. So we want to do a gas inventory so that we can show the customer the pathway forward and on all of those things that are going to need to be done so we can really plot the plan for them. And then size up the floor plan. I don't go into any house where I don't break out my grid paper and measure the house and measure the windows and put all the information in, because I'm going to do a load calc on that house. And so the other thing is we also want to make note of where the registers are. We don't want any of those registers to be under furniture if that system is in the floor. And we don't want them to be blowing on the homeowner when we're putting in a heat pump. Heat pumps heat with a little bit cooler air. They warm your house. They don't heat it like a furnace does. So we want to keep the air up off of the homeowner. And that's really easy to do with the right type of registers. But in order to do it, you need to know how many there are and what size they are. And take tons and tons of pictures. It's like we end up in our files, we end up usually with about 160 pictures of each project with the before and after file. Present your findings to your customer. Well, the way I always did it is I took my pictures with my smartphone and I bumped the pictures over to my iPad and I shared the pictures on the iPad one at a time, showing the deficiencies in the building envelope or the deficiencies in the ductwork and explaining this is what this does, this is why this needs to be handled. And most of all, share their electrification opportunities. Share the opportunity of replacing that gas water heater. Maybe you're going to go in and install a new heat pump system, and you might want to run the electrical to that water heater so that when their water heater dies, they don't have to worry about scrambling to get an electrician out or doing whatever they need to do. It's really nice if there's a nice 240-volt plug right there, and you can just send your guy out with a heat pump water heater and plug it right in. That's the biggest problem that makes people go back to gas is it's surprisingly short time that people are willing to live without warm water or hot water. And remember that most houses in California are going to have an electric car at some point. So keep an eye on that too with the electrical panel. And a lot of houses don't need new electrical panels, but some will. And then present that solution for their need that you've discovered during this process. So we're going to talk about some of the common objections that we see out there. And most of these are objections I used to have to field when I went out to somebody that called for a new furnace. And I worked at a company in the Bay Area for a number of years before I started this. And in 2015, I just threw it in. I told the owner of that company, I'm not selling furnaces anymore. I'm not going to do it anymore. I'm not going to stick somebody with a soon to be obsolete appliance. I'm just not going to do it. If I can't get the heat pump sale, I'm not going to make the sale. And so that really forced me into really polishing my process and communicating the benefits and features with the customers and finding the need and drilling down on that. So these objections, a lot of them come from being across the table, talking to someone that has a furnace now, and we are offering them a heat pump solution. So this is from the HVAC news. There's still misconceptions out there, and this was a headline heat pump awareness grows from residential customers, but the industry still needs to overcome outdated objections. And this going back, I've been in the trade for 40 years. When I first started as a technician, I hated heat pumps. I hated them with a passion. They were noisy. When it got really cold outside, it was heat pump, heat pump, heat pump after one after another call. They were always either icy or making loud noises, or the customers just weren't comfortable. I just really didn't like heat pumps. And at that point, they were just a thing that you had if you didn't have gas ran to your house or you didn't have propane. So the people that had the heat pumps didn't have those utilities in their house. And so a lot of us in the air conditioning trade are still kind of reaching back to that, like, heat pumps kind of suck thing. But heat pumps don't suck. Heat pumps are awesome. Technology has moved forward on a lot of things. So the right size heat pumps bring big benefits. When we size these things up right, we're providing better comfort, super, super quiet operation. In fact, most of my customers can't hear these things running. Much safer. They're super environmentally friendly. A lot of our systems, because we do home performance measures at the same time, we're able to put in systems that are dramatically smaller. And the smaller those systems are, the less amount of energy they use, the quieter they are, the less amount of air they're putting through. And these systems have the ability to speed up and slow down. So they meet the need of whatever the temperature is outside and inside in real time. And so because we're running these systems smaller and longer rates, we also get great indoor air quality because we're mixing the air for a long period of time. So we always pull our systems through a really, really good filtration system that's designed for a unit that's 3 times larger, so it doesn't cause a lot of pressure drop. And then we put really big return airs in, so there's no sound coming through, and the house is just warm. You walk into the house and it's just comfortable. You don't hear it running. You don't feel it blowing on you. The heat pump technology of today is just completely insane. So we still get this one a little bit, but mostly it's a little bit different than we do. It's like, I didn't realize it was going to cost that much. But we get that it'll cost too much to run thing, and it'll cost too much to own thing. And the way we do that is we justify the incremental cost versus the existing gas bill. So because gas is so expensive now, there's never been a better time to be able to offer a heat pump that is actually going to save money as well as energy, because we know gas has always been very inexpensive and electricity has always kind of been up there. So even though a heat pump, a lot of them will operate at near 400% efficiency, it was still less expensive to run gas for a long time. But that gap has been closed. So if we can justify that incremental cost versus the gas cost, that gives us a lot more room in the return on investment. And then we talked about them because we took the time to figure out what their needs were. And I can tell you, the amount of customers that call us and want us to reduce their bill, usually that is never one of the conversations we have. They want to have more of an environmental approach. They want the house to be safer. They've heard from their friends that heat pumps work good. I mean, we get all of our work from them hearing from their friends who happen to be our customers. There's rebates and incentives. There's a lot of carrots out there, or starting to regenerate now, carrots out there for people purchasing heat pump systems. And we don't want to wait too long on that, because as the carrots wean off and we get closer to the goal dates, there's going to be some sticks involved when we have the infrastructure things that are going to come up in the cost of these. So getting them installed now while there's rebates and incentives and it can help offset some of that cost is really extremely important. Offer several financing options. You know, we say this all the time, and this is something, if you're out there as a consumer and you're looking to purchase a heat pump system, keep your eye on those no interest financing programs, because there's usually a lot of cost that's built into the job to cover that, because there's no such thing as free money, especially in the home improvement business. And when you're being offered a long-term zero interest financing, you're paying up to 18 to 20% on that job. It is to cover the cost of that financing. So we use GoGreenFinancing.com. Go Green is a state-supported program. They work with PG&E and a lot of the other investor-owned utilities, and it's a low-interest program, moderate interest program in some of the terms, but also there's no fees. And one of the nice things about Go Green is you deal directly with the credit union, so you don't have to let somebody that you don't know have a bunch of your financial information. It's a really streamlined program. So that's the only one we use now. And we get this question all the time too, when there's one of those personality types out there, and part of it is it gets into that driver personality, is they want to talk about the ROI and how is this thing going to ROI. And a lot of the times when the ROI guy, we have a little joke at our office, is most of our ROI guys have like a Mercedes or some sort of an expensive imported car on the driveway. And so I usually ask, what is the ROI on your S500 out there? So, or your iPad, or any of these other things that you're buying to make your life better. It's only because it uses energy and there's a potential to save energy that people are even looking at this as an ROI in the first place. And if we have our information we need, we have the specifications on the unit, and we know how much energy they're using now, we can help them with an ROI. But remember, people are going to use these systems differently. And we don't know if we're putting a system in a house for somebody that hasn't ran it for a year because it costs too much. So ROI is tread carefully, and then bring them back around from that on why this is an investment that goes beyond just the payback. We still get this one a lot. Electricity is more expensive than gas, and I just tell people mostly just, have you been paying attention? But natural gas prices are on the rise. We've seen that. If we could see raised hands, I'm sure a lot of you would raise your hands out there that don't have heat pumps now, that would say, how have your gas bills gone up? Right? Gas bills are just going out the roof. And gas bills are a spot market commodity. They're going to continue to react to things that are going on in the world, as well as availability and selling to other countries, whatever it is that's driving the gas prices up in your particular area. That is putting a much closer cost to the electric you would use. And with the electric systems that we install, because they're all based on performance and low energy use, this is not really a big deal to us. But as you can see in this graph right here, the average natural gas price and the California average natural gas price are not that different. So it's not really changing that much. And if you see the little linear line there, it's our average natural gas price. It kind of stays static, but it's definitely on the approach. You can see that in the last few years, it's really spiked. And as we get closer to 2030 and more people are electrifying, and there's less people kind of carrying the bag of the maintenance commitment on the gas system, prices are going to shoot up even higher. They were talking about, experts were saying it could quadruple in 10 years, 3 years ago. So we're seeing that happen in real time right now. So having high gas prices and having them be unstable is right. And another thing we talk about is you can't ever replace a gas bill with a solar panel. This is one that we get quite often, and usually this is just kind of a passing question with our customers, but it's like, what happens if the power goes out? And so most of the time I start off with asking, what happened the last time the power went out? And most people will say, I don't know, everything was turned off, and like including your furnace. The only thing that continues to operate after the power shuts off is really your gas water heater, if you have a traditional tank gas water heater, which quite a few people still do. So there's some sort of a real objection there that we can overcome. But most modern gas appliances are using electric ignition anyway. I've seen a new stove technology recently that the customer was telling me that they couldn't even turn the gas on and light it with a match because it had to use the electricity to open the valve. So a lot of the smaller inverter systems we install can be backed up on batteries, although don't super recommend that. The power doesn't go off for long enough usually for most people to justify installing their heat pump system on their battery. That could really be, you need a lot of battery power to do that. And then, how often does power go out in the winter or summer? The times that the power's failed in my neighborhood, and it's failed a few times, and I'm fortunate enough to have a battery on my house that I bought years and years ago. It's like 6 years old now. But when the power goes off, I don't really notice, but I do notice that my neighbor's power is out. But usually when the power goes out at our house, it happens in the middle of the night or for a couple hours during the day. We did have one time when it was out for almost 24 hours, and the battery carried us through. And my neighbor was out front, and he had his refrigerator plugged into his little generator he had. So it's not really a great argument worrying about when the power goes off. We've lived through power outages before. It's not going to change anything. So there's also an advent of new technology that's coming out with battery integrated appliances. And this very smart guy in Berkeley from I can't remember the name of this company right now, but they've developed a induction range that has battery backup, and it plugs right into a 115 volt outlet, and it charges a battery, and any power that unit needs more than that 115 volt outlet will apply comes from the battery. But also the battery, when the power goes out, turns into a backup battery. It will run one burner, and it also has a plug you can plug your refrigerator into. So I'm seeing the advent of these battery backup appliances really taking us a long way with this. Well, we hear this one a lot. The grid can't handle more electric appliances. Well, part of that is probably, this is something that is a top of mind of a lot of people. We had some recent things happen that have discouraged some people, and it's brought up to us a lot. It got really hot last summer, and people that owned electric cars were asked not to charge them. And that was like a few days after they came out and said you could only buy electric cars in California after 2035. So that was a weird, awkward little time where we had to explain things. But you know what? Our grid has a lot of capacity. We do need to be mindful about our new heat pumps and electrification systems, which is why we're in business, is to put systems in that are very efficient and are going to utilize as little energy as possible to do this. If everybody installed heat pumps thoughtfully, well installed, and took care of load reduction in the house, we wouldn't need to worry about all this. But a lot of the heat pumps that are going to be installed over the next 10 years are not going to be thoughtfully installed. They're going to be just thrown in. And those units are going to use a significant amount of power. And we are going to have challenges because when the power grid is stressed, when that hot day comes, and the 5 million people in California, 3 million people in California that don't currently have air conditioning, and there's a heat wave, and people remember, hey, I have a heat pump, it has a built-in air conditioner. Those low efficiency heat pumps that were installed in heat only houses are now going to become air conditioning plants. Those could put a real stress on the grid. But realistically, resilience is the top of mind of the utilities, and failures are a political nightmare. We have a goal set on this thing. There's major investments being put into solar farms and CCAs and all these different approaches to bring more energy into the system. So I'm confident by the time we'll get there, we'll be okay. I'm a little bit more worried about charging electric cars, but for the heat pump argument. And then there's a lot of these technologies like heat pump water heaters that can really be optimized to not run during peak rate. And you can program these units to run during the night when the energy is cheap, or run it during the day when there's just a massive glut of solar power on the grid. We had a customer ask us this the other day. She says, my neighbor got a heat pump installed. First of all, she says, it's very noisy and it blows cold air on them when they're trying to heat the house. Well, so those are two things that my heat pump systems don't do. But really, realistically, we have to understand that heat pumps don't heat your house, they make it warm. And so you have to use them differently. And correctly installed heat pumps We'll keep your house as comfortable as you need it, whatever the season, whatever's going on outside and inside, because we use design that does that. We design them for an outdoor temperature and we design them for an indoor temperature. And as long as we're within that design criteria and we do everything we need to do right, these systems will condition no matter when they need to. But heat pumps, especially traditional single speed heat pumps, do get frost on them when it gets cold outside. And the way that they defrost is they switch over into cooling for a short period of time. That can be uncomfortable. So one of the things that we need to do when we install these systems for all you guys out there is put registers in that don't blow air on the customer. We had a class last week, and the guys at that class, they were talking about how their customers prefer to have the air blown on them so they can feel the cooling. And I said, the problem with your argument here is you're blowing cold air on these people because you didn't take care of the building envelope and make the house comfortable. If we have to blow cold air on somebody rather than just keeping your house at 72 degrees in every room, that's because the job wasn't done properly and the system isn't running long enough to get the house cool. It's just chilling the air. So we really need to be conscientious about this because the effects of these are very different. The furnaces tend to run 125 or 130 degrees supplier temperature. If they're restricted and they have bad airflow or a dirty filter, they can even get up higher than that. So heat pumps don't do that. So we just need to direct the air away from the customer by putting in the right type of registers. And as you can see the little chart here, our bodies transfer heat in a lot of different ways. So the convection in the room, but what we really feel is radiation. So if the whole room is the same temperature and it's the same room to room, and you can keep your house 69, 70, whatever you choose to be comfortable at, if the whole house is that temperature because my heat pump is running longer while using a fraction of the power, it's going to be comfortable, and this all goes out the window. It doesn't matter if the air is hot coming out of the vent. This is all part of an old paradigm. So this is an easy objection to overcome. Heat pumps don't work in the cold. Some don't. A traditional heat pump system that runs at one speed is going to lose a massive amount of its heating capacity as soon as it gets below 41 degrees outside. And so it gets colder than 41 degrees outside a lot. So it's all based on what the refrigerant temperature in the heat pump can come back at. So in order to get the refrigerant temperature down low enough, and most of those single stage units are operating at about 20-degree return refrigerant temperature into the outdoor coil. So we have 20-degree refrigerant going in there. If we pull 41-degree air across that, there's quite a bit of heat we can grab. But as soon as we start getting below 40 and that differential in temperature is less than 20 degrees, it's harder for these systems to work. And so they start giving a little less heat out the other end. But if we install the right system, we don't need to worry about any of that. Inverter technology has taken this problem away. So right sizing these systems so they run longer and don't turn on and off all the time, and the house is already warm, that's an easy way around this. So heat pumps do work less well in the cold, but the right heat pump will do fine at most of the ambient temperatures in California. California has great climate for heat pumps. Now, we've seen in the news a little bit lately, there's some areas that got a little snow going, right? And I was watching the LA news report the other day, and people can't use their furnaces because the flues were blocked on the roofs because there was so much snow on the roof, which would be a similar problem to having snow covering your whole heat pump. But if you're in the mountains and you build it in the correct enclosure when the snow is not getting around it, but nobody was counting on 10 feet of snow in the Los Angeles mountains. So there's always going to be these anomalies that only, you're going to have to figure out how you're going to heat your house up. But fortunately, a lot of those people are pretty resilient. But everywhere else in California, heat pumps are amazing. When temperatures are mild, having a large system in your house is not conducive to good comfort. having lower temperatures coming out of the vent is also better for the whole envelope of the home. So a furnace that puts out 130-degree air in a house that doesn't have good attic insulation, that air is going to all sit at the ceiling, and it's going to activate that insulation, and it's going to drive the heat through the ceiling and pull in cold air behind it. If we take care of the envelope and we put a heat pump in that can heat the house at a realistic temperature and a temperature closer to actually room temperature, we don't activate that insulation, and it keeps the house much warmer. So if we keep our house warm and it's a nice little sealed box and it's well insulated, when it gets cold outside, that unit doesn't have to work as hard. So this is not a good objection anyway. So they work a little harder on the coldest days of the year. And then there's also, for sub-zero climates, they have cold climate heat pumps that work extremely well. We've learned a lot about cold climate heat pumps over the last couple of years because we've had some of these polar vortexes coming down. And it might surprise people here to know that some of the states with the most heat pump proliferation are up in the Northeast, where it gets extremely cold. And so in some cases, they may have to install some sort of a backup heating element or something like that. But the cold climate inverter heat pump systems can work all the way down to sub-zero temperatures with no problems. Well, we get this one a lot. It kind of harkens me back to that picture of that beautiful, architecturally gorgeous modern home. Is we get this objection, and we don't traditionally install these wall-mounted units or ceiling-mounted units, but we hear this all the time. Is like the company that we talked to yesterday said they want to put these units on all the walls in the house, and they told me it's going to be great because I can turn every room on and off, which is not a great idea anyway. But and they say, you know what, my more aesthetically choosy partner is not 100% on putting these things on the wall. And there's a couple of solutions for that. You can go with a ceiling mounted unit. In this case, I would just empathize with them and say, you know what, I wouldn't put those things on my wall either, and we don't install them on a lot of walls, but we can have a solution for you where I can take all the rooms with one small unit, and you're not going to see anything. That sounds like a better way to go, right? So that's an easy one to get by if you're doing the right thing. If you look at the picture on the right there, that is a very small 18,000 BTU system, an air handler in the attic space with the ductwork and everything. We installed that one in Corte Madera. It's on a significantly sized house. It'd be 12 to 1,500 square feet. The design load in Corte Madera is very low. It doesn't go below freezing for the load temperature, and it doesn't go above 90. So a small system like this can do it. And instead of installing a bunch of units all throughout the house, we can put one of these small units in and just take care of the whole house with one small system. And the picture that you see there was before the ductwork was buried. So they came in behind that and put insulation over all those supply ducts. Unfortunately, the way the return duct come in, we couldn't bury that. But that's a great solution for that technology, or excuse me, that application. This was my neighbor. My neighbor was like, I've been heating my house with gas forever. Why do I want to get away from gas? And it took me installing the heat pump in my house and showing him how quiet it is and how comfortable it is and how I didn't really have a gas bill to speak of anymore. But you're going to run into these people out there that are really kind of like, I don't want to go away from gas. I know it. Them heat pumps, I've heard bad stuff about them. The neighbor down the street got one. It blows cold air on them. And that's part of the problem, if I digress a minute. But that's part of the problem with a lot of heat pump systems not being installed with better performance, is that those people are going to talk about that to their neighbors. And they're going to go, well, I got my heat pump installed and it sucks. Fortunately, I've got a half a dozen neighbors on my block that I can hand out a phone number and they'll tell you how awesome theirs are, and all over the Bay Area for that matter. But we got to find out what the driver is on this. And one of the things I notice a lot is how people communicate. and we had this conversation with a guy, and it wasn't one of my customers, but it was a neighbor of one of my customers. And he was like that inquisitive kind of neighbor that had to give his advice to everybody. And he came over there while I was talking to the customer, and you know, she was a little annoyed that he came over. But then I started talking to her, and he literally was interrupting me, telling her that it was a bad idea for her to even consider changing from gas, and that he had just gone through and converted everything in his house to gas. Kind of wondering what that guy's gas bill is now. But I noticed that he had a phone in his hand, like an iPhone in his hand, and I asked him, I said, you used to have a landline in your house before you had a cell phone. Yeah. And I said, you probably had a flip phone before you had an iPhone, right? Yeah. And I said, so you've embraced technology in that way, but you refuse to hear about technology in this way, because technology now exists where I can heat this home for less cost and more comfort than you will ever get out of a gas system. And it's not something that we're going away from gas because it's a bad idea. This customer wants to invest in this because they want a more comfortable home. And I don't remember how that argument all came out. That was a number of years ago. So what is their driver? Figuring out their driver and relating other things to do. Like, who doesn't pull up at a stoplight and see a Tesla and want a Tesla? I'd love to have a Tesla. In fact, I was counting. I was at Sacramento a couple weeks ago, and I was at one stoplight. There were 6 Teslas at all 4 corners. I'm going, that's very interesting. But our automotive stock has changed from the Model T to the Tesla. So why are we so entrained in having this gas technology be here? It really doesn't pencil. And then we talk about the things, like the pollution, and pollution isn't everybody's thing. There's a lot of people out there that are switching over to this that are not environmentally minded really at all. Like the picture of the house with the solar panels and the Hummer. Like, they wanted lower bills, they got a solar panels, and they want the new kind of sexy technology that's going to keep their house nice and comfortable. And that's the way we communicate these to those people that aren't environmental. So we can go with safety or rising gas cost. They're super clean. Like, we know that we see these ads on TV every year for safety inspections on gas furnaces. And I put this question to one of our classes that we had recently, and I'm like, we have a picture of a cracked heat exchanger, and I'm like, wow, what does everybody think of when they see this cracked heat exchanger? And of course, it's a bunch of service technicians and salespeople, and they go, oh, ching, that's what this is, money. And I said, last time you found one of these, what did you put in? And they said, oh, we got a new furnace in there. And I said, so you found a system that was potentially dangerous for this family, and you didn't offer them a less dangerous or more safe solution? Says, we need to start rethinking these things. So when we switch away from gas, it gets rid of our gas leak issue, our CO issue, and just all of those indoor air quality problems that come with running gas systems and turning them on and off all the time. Many people don't understand or don't know that your gas furnace has to run a 20-minute cycle before it gets up to what they call steady state. And steady state is where all the engineering on that unit is based on. So if that unit hasn't had a chance to warm up for 20 minutes, it's going to wear itself out really quickly, because it doesn't have enough time to dry out the condensing water that's condensing on the inside of the heat exchanger. And then also, it doesn't have a chance to fully warm up and get the flue working properly to where it's actually operating at that efficiency that it's operating at. So oversized furnaces are even worse for that. So between cost, safety, and better comfort, we can always get around this one. I hope I'm not running ahead of schedule here. We hear this a lot too. They're too loud. And heat pumps are not created equally. So you see on the left there, that's what we call a unitary heat pump system. And if you look at the brochure on those, it says, yeah, as quiet as 74 decibels. And in the world of inverter technology, which you see here on the right, 74 decibels is like unthinkable. Like, there's no time when these are ever going to be that loud. And the other units are kind of, the unitary stuff is really kind of bragging about being that quiet at 74. And the inverter stuff is like never going to be that loud. So there's a lot of different brands and technologies out there. We prefer the one on the right here, the 54 decibel. This is what one of our inverter technology systems look like. It's basically a mini split that operates with an air handler. So it serves the need in the house just like central heating and air, but it uses this nice compact, super quiet unit. These units don't have the loud gushing sound that a traditional heat pump has every time it cycles off. It doesn't grind away out in the backyard during the summer. And I don't know if any of you guys live in air conditioning neighborhoods, try to enjoy your backyard. My air conditioner is dead quiet, but I can hear all of my neighbors' air conditioners. If everybody in my neighborhood switched over to an inverter air conditioner, it would be a gloriously peaceful place to hang out in the summer. So being too loud is only because of the choice that is made. We hear this one too, and this is something that is really prevalent in a lot of the cities around the Bay Area. There's sound, and there's also space issues. And so here's just a couple of examples of how we save space. You see here on the left, obviously a wall-mounted system that we could put up there. This particular one is obviously, if you look at the picture, not residential. That's in a restaurant here in my town that we installed. And they had all this other equipment and all these other things out there. There was no place to put it, but we were able to mount this unit right up on the wall and go right in. So space-saving design. When that unit is measured from the wall to the edge of the unit, it's only sticking out 20 inches, so not much. At the top right, we put the units up on the roof. This is a condo complex that I did a number of years ago. And we put the little units in the closets downstairs. All these condos had wall furnaces in them, and multiple air conditioning and heating companies came out and said, we can't put heating and air conditioning in here because there's no place to put an air handler and there's no place to put your outdoor unit. And we put the air handler, very small, thin unit, inside the master closet and ran the ductwork right inside the building envelope and put the units up on the roof like this. So all the other companies they talked to said there was no solution. We had a solution going for them within minutes. Down here on the bottom left, that's kind of a cool system. That's a Sanco water heating system, but we were able to tuck that whole thing underneath the staircase, the little deck in the backyard, because these units are so small and discreet. And she can't hear that thing at all. There's no sound coming from that she can hear in the house or in the backyard whatsoever. And so all of these solutions met that I don't have space argument. This one I hear too, like we've heard, and mostly I hear a lot of these from other HVAC salespeople are kind of what they're hearing, but like, what about the embedded carbon in the manufacturing process? And I'm like, okay, well, what about the embedded carbon in the manufacturing process of the furnace? Like, you're into that. When you're replacing this equipment, there's embedded carbon in the entire process of making that. But do you want to continue to create carbon through your choices, or do we want to stop here? So we get this question quite a bit. Is like, what is the environmental carbon impact of this system? And it's far less over the life of the system than putting in any gas appliance, first of all. And it also, we see on the chart on the left, the emission impact by state, heat pumps versus gas furnaces. At the time that was done, 46 of the lower 48, you could get carbon reduction from any heat pump in any of those areas. The two that you see here, which is Utah and Colorado, they had a fair amount of energy coming from coal. So if you use the energy there, it was creating a bit of coal. It was created by coal, so that it changed the dynamic a bit. But then Rewiring America came down, and they said, we're going to relook at this and revisit this. And what they found is that 98% of all the households in America could cut their carbon emissions by installing a heat pump and replacing their gas system today. So there is no better option for being carbon friendly if they want to live in a conditioned home. So it comes down to the choices. And this is always going to be the better choice. And the system that uses the least amount of energy is obviously going to have the lowest carbon footprint and cost less over the time that you own it. Oh, this one we get all the time, right, Alex? We get this one all the time. And so a little bit about how I live in my house. I keep my house pretty much the same temperature within 3 degrees all winter, between 72 and 69 degrees. I never let it go below 69 degrees because when I do, it uses more energy to heat up again. So my wife and I, we like to sleep cool, my wife especially. She likes to sleep cool. So what we do is we just let that unit continue to condition our house and keep the house at 69 degrees all night. And she opens the window and it gets frigidly cold in the winter in the room, and I'm like freezing and she's throwing the blankets off. But that's the solution with these. If we turn them off at night and let the house get bone cold again, they're going to use a lot of energy the next day to reheat the whole place, and it's going to take a long time. You're not going to be satisfied with it. So by leaving that inverter technology system on, my particular system, I can run it for 1 hour at full blast, or I can run it for 6 hours on basically kind of cruising speed, and with it just cycling on and off using very little energy. And so it's worth it for me to keep the house warm all night rather than running it 2.5 hours the next day on high speed to try to heat the whole place up again. It's just wasted energy. So small setbacks are okay. Large setbacks must be done very carefully. And when customers tell me that they want to set them back that far, I'm like, you're doing that at your own risk. It was designed to keep your house comfortable and use a very small amount of energy. With these systems also, you need to keep an eye. If you have a heat pump system in your house and you're not using it, it's the shoulder season, you need to keep an eye on the weather report. If it's going to be really cold over the next 2 weeks, you want to get the house tempered, get the house warm, just leave that thing on, because the heat pumps do have a hard time heating up a cold house on a cold morning. The technology is just not there for that. So this is a minor adjustment you can make in the way you live in your home so that you don't have to have a gas furnace anymore, right? We're trying to get rid of gas and electrify. It's going to change. We're going to have to change our habits just a little bit. But the biggest part about this is we need to set these expectations with the customer before they buy. They need to understand that they're going to have to do it a little bit differently. We had a customer that called a couple of weeks ago, and they had 2 other contractors come out. They were a customer in Berkeley, California, and they were shopping bids, right? They had 2 bids that were close to each other, and they were calling us and saying, hey, I really heard a lot of good things about your company. We're excited to talk to you, but I've got these 2 bids. And I says, well, I don't really need to know what your bids are because I'm going to give you a solution. But first, what I want to do is set the expectations and learn about how you live in your house. And it came out through that conversation that they turn the thermostat all the way off, and their house gets as cold as 55 degrees a couple of times a year in the night. And neither one of these other guys that dropped off a bid took the time to tell these customers that they're going to have to live with the system differently. And so we took the time to explain what I just explained to you, to that customer, and they were okay with it. They were just like, okay, we really want to electrify. We want our house to be efficient, and we've got the solar on the roof that we want to take advantage of. So we're willing to make this little bit of a change and keep our window open in our room at night, but keep the house warm. And so it was fine. But if they would have went with either one of those other bids, they would have not understood that, and that company would have got a call, or they would have been dissatisfied with it and probably told their neighbor, like, I really wanted a heat pump, but it doesn't heat my house up, because they were never told how to use it and never told that they need to change their lifestyle a little bit to make it work properly. So that's the way we do it. And then kind of zoned, like when we're doing a 2-story house, we're doing one right now. It's coming up in a week or so. And we're taking out one big system and we're putting in 2 really small ones. So there's a small one for the downstairs and a small one for the upstairs. And so they're going to have individual zoned control, but through 2 very small, very efficient systems that fully modulate and will keep that house perfect. Because right now they have a big giant system with this like dampered zone control valve thing there's tons of those out there. And you know, when it comes on upstairs, it blows like crazy, because basically what's happening is half of the airflow is shutting off to downstairs, and it's forcing all this air through the ducts. So this guy's thing was, it gets super cold in my master bedroom on summer nights when the unit comes on. It goes from being uncomfortably warm to uncomfortably cold, and it's so loud that it wakes them up. And so we're going to put in a tiny little system up there that they're not going to hear. The registers are going to be changed so they're not blowing on them, and it's going to keep the whole upstairs exactly the same temperature. So zone solutions can also be a good solutions as well. So hey, we're at the end here. So I've got a couple of more minutes for questions. Thank you so much for joining us. I hope this was informative.